Hi everyone, Engineer Liu here. How are you doing? So for this video, I would like to talk about double pointers or pointer to pointer, how they work and what's their purpose, what's the case of usage. And for that, I'll be talking about give an example using a matrix. And by me matrix, I mean the algebraic matrix using linear algebra, like you have rows and columns, and you can have all sorts of operations with them. You can use to store data. It's a lot used in machine learning algorithms, like you have this matrix and you have perform all sorts of mathematical operations with it in order to obtain weights for your data, to train your models, and so on. So yeah, a lot of machine learning algorithms use matrices, also computational physics, computational mathematics. So yeah, if you're into that, if you're using C for that purpose, that this video should be very useful to you. So yeah, let's get started. First of all, you might be noticed that the previous videos I use Vim for as a text editor. So for now on, I probably will be stick to using VS Code. So yeah, to basic to make our life simpler, and yeah, that's our kind of thing. So. Basically, I will create a struct for a matrix. I type definition struct. He will have unsigned int for the rows m. Okay, unsigned int, and for calls and the columns, right? And then we have the values itself, which will be a double pointer. You will see why. So I guess it should be a float. Yeah, let's make it float. Floats v, right? So this pointer, double pointer here, is where let's see company here. Okay, so yeah, let's call this matrix. And yeah, so this pointer to pointer here. So why would we use a double pointer? Why can't we just simply, create a matrix, int matrix, something like that? That's what we would do if we knew how many rows and columns our matrix has, right? So the basic usage for a double pointer would be if we at runtime, before we execute the program, we don't know which is the size of our matrix, right? So which will be working. So for that we'll be needing dynamic memory allocation to establish our matrix size during runtime, during the program execution. Okay, so yeah, that's the main reason why we do such a thing. So we can take these two parameters, the rows and column size, by argv from the command line arguments. So yeah, let's check that. If argc less than 1, we print what's the company. Okay, I will print to the standard error. Okay, usage, let's call it main, and then number rows, num columns. Okay, so these two would be parameters. And else if argc is less than 2. Actually, you could use or here. argc is less than 3. We simply print the stutter. So here we will have 1, 2, and 3. And in either case, we print it like this. Okay. So then we declare our unsigned int. Let's call it rows a to I. Remember, we have to convert a string to an integer, so use a to I function. argv1, and then columns a to I argv2. Okay. And yeah, so here we simply return exit failure. So we exit the program in case it doesn't enough we don't have enough arguments provided here. Okay, your line. All right, so yeah, now we declare a matrix. I believe we can use pass it by reference or a double pointer. To a matrix. Yeah, so actually here we can simply use a matrix like this, right? And then right now we should write a function to allocate memory for a matrix. Okay. And all right, so I'm dealing with floats here, but it could be double if that's what you need for your program, but I'll simply call it allocate matrix like this, and then we'll take as an argument unsigned int m, unsigned int n. Okay. And so we guarantee that we don't have a, and this will have to return a double pointer which will point to this. All right. Okay, so we create a float a here, which will be the pointer that will be allocating memory, and then we'll call malloc to allocate memory, and then return the pointer, the double pointer here, to this member here. Okay, hope that makes sense. So yeah, well, first things first, first we need to allocate memory for each. Let's say we have to allocate memory for the pointer itself, right? And then yeah, basically we allocate memory for the double pointer based on the number of rows. Okay, so a here will be equal to, we cast it to float, right, to a float double pointer malloc m times size of a float pointer. Okay, so yeah, if it fails to allocate memory, then we check if a is equal to null, and then we can print to the standard error, fail to allocate memory, and then we exit. Okay. Right, so now that we allocated memory for the rows, we have to allocate memory for a sorry, we have to allocate memory for each column, right? So the way we do this, the thing is, for each row we have a pointer, right? Because we're dealing with double pointers, so we have a collection of pointers. That's why we use we are using a matrix, right? We have, if you think of an array, to make analogy with an array, you have a pointer which will allocate memory continuously in memory, okay? But now with a matrix, at least a two-dimensional matrix, we are taking each one of these pointers, which is an array, and for each one of them we are allocating another array. So you can think of in that manner, a pointer to a pointer, okay, which then each pointer leads to another array. We have a collection of arrays, okay, so a collection of pointers, a pointer of pointers. So that's why we call it a two-dimensional array, or simply a matrix, right? So yeah, I've been needing an auxiliary variable here, which must be assigned I, and we create a loop, I equals 0, I less than m, because we are iterating through each row here, and then I plus plus, and for each element of for each row we're going to allocate memory. So now it's actually not a double, it's a float, and we call malloc n, which is the number of columns times size of float here, and we check if an error occur. Okay, what is he complaining? Invalid type conversion. Oh yeah, we have a pointer here. We had a pointer to a pointer, and now a pointer simply. And if I is equal to null, actually we could write this to a function. Yeah, let's simply leave it like that. And yeah, actually we could write our own malloc function that checks for error, and I believe we did in another video that, but yeah, we simply leave it like that for now. And yeah, so just to recap, here we allocate memory for each row, and then for each row we allocated memory for the columns, right? So we are iterating through the rows and then allocating memory through to the columns, right? And then at the end we'll have a double pointer to an allocated double two-dimensional array, and we simply return a, right? What we could do is pass this by reference, right? So yeah, we could pass it by reference and then return a pointer to a pointer here. Yeah, we could declare it like this. And then yeah, but just leave it like that. So now we have to write a function to free the memory, okay? So we call it a, I guess it could be void because it returns a null pointer. Yeah, we just call it a void free matrix like this, and we take a, let's say, floats a like this, and then we can check if it is already freed, and we believe we did that with when I talk about dynamic memory allocation, but we just simply leave it like that. And actually here we could write simply a matrix matrix, and then we check for unsigned int I auxiliary variable, and then we iterate like this: I equals 0, I less than matrix dot m, and I plus plus, that's a complaining identifier. Okay, and then actually we don't need this here. We can simply write free matrix dot v, which is the value of I. So we're going to iterate through each row and of a matrix, and then free the columns. And after we are done freeing the columns, we have to free the rows, right? So we call free again on matrix dot v, and yeah, we have we free the pointers, and then the pointer to a pointer. We do the process backwards, if you think about it. And yeah, I guess we don't need to return anything here. So yeah, I think we're good to do some testing. Okay, here we have our columns and rows, and yeah, let's try it out. Matrix dot v, which, if you recall, it's a double pointer, so we allocate matrix, and then we pass in the rows and columns, and then after we are done with it, we simply free matrix, and we pass in the matrix itself. And I think we're done. We can test it, but actually our program won't do anything. We should write a function to read some values from the user, and then print on the screen, something like that. But yeah, let's give it a go for now. So yeah, so gcc wo warnings main.c main.o control reaches end of non-void function. Function free matrix 44. I guess it's complaining because we're dealing with a double pointer, so we return null. Yeah, that was it. Yeah, so let's pass it 2 and 2, and everything seems to be working. So we actually need test this, we should write a function to read values from the user, right? So, okay, let's write a function called, or we can simply use here in main. Okay. Let's create a variable, auxiliary variable int I and j, and yeah, for I equals 0, so basically we will query the user to insert values for each row, each element of the matrix. So I'm using scanf. I know I talk about scanf, which is not safe and we should be avoiding it, but for this tutorial, for the sake of simplicity, I will use scanf. So yeah, but avoid using it in sort of production environment. Okay, so this is for tutorial purposes only. So type the value for a, so yeah, here we will take element by element. Here will be I and j, then scanf, it will be a float, which will store on matrix dot v I and j, I believe. Okay, and then after this we can print the matrix. We could do something like printf. And yeah, we could leave it like this. And then each Leo9 print a new line for a whenever we switch a row. Yeah, I think we're good to go. So yeah, I think we can test it. We compile, double. It's a float. Okay, so I guess we need to pass it like this. Yeah. And then we execute it. Let's take just 2 rows and 2 columns. It's a 2x2 matrix of 4 elements. Okay, so 1, 2, 3, and 4. Okay, so yeah, it seems to be working. and let's give a 3x3 matrix. 1 2 3 4 5 6 7 8 9. Yeah, here is our matrix, and then we can perform all sorts of mathematical operations with it, with the matrix which was generated using dynamic memory, right? So yeah, I guess this is it. I'll be uploading this in the GitHub and posting the link for the source file in the video comments. So yeah, hope you liked this video. Don't forget to like, subscribe and comment, activate notifications, and share this video with whom may be interested in this subject, who is learning about the C programming language. And yeah, see you next time. Bye.